In this video, we are going to discuss the difference between the sample mean obtained from the sample and the population mean as claimed is significant or not. So let's discuss the test. So suppose x1, x2 up to xn be the samples observations in a sample of size n. That means we take a sample of size n from the population in which we have observations x1, x2 up to xn. The population is normal with mean mu and standard deviation sigma. Then each xi follows a normal distribution with mean mu and standard deviation sigma. Therefore, this x bar, that means mean, is equal to x1 plus x2 up to xn divided by the number of observations in the sample. And this is a normal variate because each of the variables x1, x2 up to xn is normal. Therefore, their sum is normal. Therefore, x bar is also a normal variate with expectation of x bar equal to 1 by n expectation of x1 plus x2 up to xn. The expectation of sum is sum of expectations. Therefore, we can write this formula as 1 by n expectation of x1 plus expectation of x2 up to expectation of xn, which comes out as 1 by n into mu, because each of these expectations is mu. Expectation of x1 is mu, expectation of x2 is mu, up to expectation of xn is also mu. So n into mu. So expectation of x bar comes out as mu. Now what about variance of x bar? So variance of x bar is equal to variance of 1 by n into x1 plus x2 up to xn. Using the formula for variance, we have formula for variance. Variance of a into x is a square into variance of x. Using this formula, we get variance of the expression as 1 by n square variance of x1 plus variance of x2 up to variance of xn, and each of the variance is equal to sigma square, because variance of x1 is also sigma square, variance of x2 is sigma square, and so on. So variance of x bar comes out as sigma square by n. Therefore, x bar is a normal variate with mean mu and variance sigma square by n, or standard deviation sigma by root n. Therefore, the test statistic is z equal to theta minus expectation of theta upon standard error of theta. So here standard error is nothing but standard deviation of theta. So standard error of x bar is standard deviation of x bar. So the test statistic will become x bar minus mu by sigma upon root n if sigma is known. In most of the cases it is not known. Or x bar minus mu upon s by root n if sigma is not known. So in most of the cases you have been given this simple standard deviation. Here s is the simple standard deviation. So whichever is given you must use here. So this is the test statistic for testing the significance of difference between the sample mean and the population mean. So let's take an example. A manufacturer claims that the mean braking strength of safety belts for air passengers produced in his factory is 1275 kg. A sample of 125 belts was tested and the mean braking strength and standard deviation were found to be 1260 kg and 90 kg respectively. Test the manufacturer's claim at 5% level of significance. So here mu, that means population mean, is given as 1275 and the sample mean found to be is 1260. Sample standard deviation is 90 and the sample size is 125. So here we have to set the null hypothesis as x bar equal to mu. That means the mean braking strength of safety belt for the air passengers is 1275 kg. That means there is no difference between the sample mean and the population mean, and the difference, if any, is due to fluctuation of sampling. That means the difference we see in 1275 and 1260 is due to fluctuation of sampling. This is not actual. So this is the meaning of this null hypothesis H0. Then we set H1 where we say x bar is not equal to mu. That means the mean braking strength of safety belts for air passengers is not 1275 kg. That means this difference 1275 and 1260. That means the difference between this 1275 and 1260 is not due to chance, but it is actual. Here alpha level of significance is given as 5% and the corresponding critical value of z at level of significance 5% is 1.96 for two-tailed test, because here we set x bar not equal to mu. So that's why we have to use two-tailed test. So corresponding to two-tailed test, this critical value is 1.96. So this value is here. So this is minus 1.96 and 1.96. So this is the acceptance region and this is the critical region, 2.5% area on either side. So this is 2.5% area, this is 2.5% area. So total 5% area on either sides is the critical region, and rest 95% area between them is the acceptance region. So using the test statistic, we find that this difference 1260 minus 1275 divided by standard deviation of sample divided by root n. This test statistic is minus 1.8634. And if we compare this test statistic with the standard value or critical value of Z, we find that this value falls in the region of acceptance. That means this value is in this region of acceptance. So minus 1.6 and 1.6. So this value 1.8634 falls somewhere here. So this is in the acceptance region. Therefore, H0 is accepted. That means there is no difference between the mean braking strength of safety belts for air passengers obtained from the sample and as claimed. So the manufacturer's claim is true. That means the mean braking strength of safety belts for air passengers is 1275 kg. Take another example. An IQ test was given to a large group of boys in the age group of 18 to 20 years who scored an average of 61.5 marks. The same test was given to a fresh group of 100 boys of the same age group. They scored an average of 64.5 marks with a standard deviation of 12.5 marks. Can we conclude that the fresh group of boys have better IQ? Test at 2% level of significance. Cannot conclude that the fresh group of boys have better IQ. Then find the 98% confidence interval for the average marks. So again we note down that population mean is 61.5. That means the average score of the large group is 61.5 as given. From the sample of 100 boys, the score was found to be 64.5. Sample standard deviation is 12.5 and sample size is 100. So here we set H0 as x bar equal to mu. That means the fresh group of boys have the same IQ as claimed. That means there is no difference between the IQ of 100 students of fresh group and the students in the population. And here we set H1 as alternative hypothesis as x bar is greater than mu. That means the fresh group of boys have better IQ. Here level of significance is 2%. That means 0.02, and the critical value corresponding to 0.02 is Z equal to 2.055 on right hand side. So on right side we have 2% area. So this 2% area is corresponding to 2.055. So this is 2% area corresponding to 2.055. This is region of acceptance and this is region of rejection. So if we compute the value of Z, then we find that this value is 2.4 and it is falling in the critical region. It is here. So this value falls in the critical region. Therefore, H0 is rejected. That means the fresh group of boys have better IQ. Now our claim H0 is rejected because of claim 61.5 marks is not true. So what should be the claim? This can be found by using the 98% confidence interval. So 98% confidence interval can be found using this formula where x minus mu upon s by root n, which is the computed value of z, it should be less than or equal to this critical value. That means the confidence interval will be here. That means 2.055. So this is the confidence interval. Z must lie here. So z less than Z alpha. Using Z less than or equal to Z alpha, we find the confidence interval. That means values of mu. So this implies x bar minus mu less than or equal to 2.055 into s upon root n, which implies mu must be greater than this. On solving, we see that mu must be greater than 61.931. So for H0 to be accepted, mu should not be 61.5. but mu must be greater than or equal to 61.931. That means the average marks of the large group must be at least 61.931. So any value greater than this 61.931 will make H0 true. Take another example. The guaranteed average life of a certain brand of electric bulb is 1025 hours with a SD of 125 hours. So in this case, you have been given the population standard deviation also. In a sample of 200 bulbs, the average life is found to be 990 hours. Can we conclude that the average life of bulbs is not as guaranteed? Also find the 99% confidence interval for the average life of the bulbs. If the average life of bulbs is not as guaranteed, then we have to find the 99% confidence interval for the average life, because this claimed average life of 1025 hours will be wrong in that case if we find that average life is not as guaranteed. So here we note down population mean as 1025 hours, sample mean 990 hours, population standard deviation 125 and sample size 200. And here we set H0 as x bar equal to mu. That means the average life of bulbs is 1025 hours. H1, the average life of bulb is less than 1025 hours. That means the guaranteed life is less than 1025 hours. Here alpha equal to 1%. That means 0.01. So here we have to note down the 1% area corresponding to this level of significance. So on the left hand side, this value of Z alpha is minus 2.33, which is 1.1% area on this side, left hand side. So this is corresponding to Z alpha equal to minus 2.33. So this region is region of acceptance. So let's see where this computed value of Z falls. So if we compute this Z, we see that Z equal to minus 3.95898, which is falling outside of this interval. So this value is in the critical region. Therefore H0 is rejected and H1 is accepted. That means the guaranteed average life of bulbs is not 1025 hours, but it is less than 1025 hours. Now what should be the guaranteed life of the electric bulbs if it was not 1025 hours? To find this, we find 99% confidence interval for mu using this formula. Because the hypothesis H0 to be accepted, we must have this computed value of Z greater than this minus 2.33. So we must have Z greater than Z alpha, that means minus 2.33 for H0 to be accepted. So using this, we find x bar minus mu greater than or equal to minus 2.33 into S upon root n. So on solving, we find that mu must be less than or equal to 1010.6. Therefore, the guaranteed average life of the bulbs must be at the most 1010.6 hours. But it was claimed that the guaranteed life was 1025 hours, which was wrong. Due to that, H0 was rejected. So this was the test of significance of difference between the sample mean and the population mean. I hope you understood. Thank you very much.